Hi guys, I think it's time for a final summary on the conductive ink on the magnesium experiment. You can see this guy slowed right down again. It was actually going quite well for a couple of days. So we'll have a look and compare the magnesium strip that's got the conductive ink on it and the magnesium strip that is bare. I'll move them onto the table and put the camera on a tripod so we can talk and look at the same time. Well, that's always the way with these. I've moved it and he's actually going quite a bit better at the moment. I've probably just moved one of the connections there and it's improved the conductivity. But we will still do the final analysis. We'll have a look at the conductors, electrodes, so this one is, well, let's go in close. So this one is the plain magnesium. And see, we've got a nice layer of black built up on it. We did put a little bit of salt in there to improve the electrolyte. So this black could be zinc chloride. I'm only guessing. If we look at the bottom of it, we can see it's actually perforated. It's actually eaten away right the way through. And what usually happens is it just breaks off right where it goes into the water. That's usually where a lot of the corrosion happens, and you lose half your magnesium strip, which is why I try and limit it to just sort of half an inch or so in the water. Anyway, so we got a good layer of corrosion on there, or deposit on there. We'll compare that to the one that had the conductive ink on it. Now this one, we were getting far less power from it, simply because it was effectively insulated by the conductive ink, which is a layer of carbon. And we can see here we've actually got salt crystals have built up, and it's eaten right away where the water has been able to get to the magnesium. That's actually going to fall apart there now. So yeah, I would say those are salt crystals or something similar, and they're just going to give away entirely just there. So did the experiment work in any way? Well, there is less corrosion, but not only was there less corrosion, there was less conductivity. This fella hardly moved. So then I decided to put both conductors in, or both electrodes in at the same time, and just compare how they went. So where the water's been able to get through the conductive ink, it's got to the magnesium and eaten the magnesium away. So that part is probably reasonably okay. Except that I'm getting carbon on my fingers. And this one is similar. I rub the deposit off it. We've still got magnesium underneath, but it's completely eaten away on the end. I suspect if I pop that back in, there we go. Oh, let's zoom out a bit. There you go, it's running fine on that. There's me bit of blue tack just to hold it out of the way. So, back to the question, did it help putting the conductive ink on it? I would say no. It has stopped it corroding where the conductive ink has managed to protect it, but where the water's got past it, it's eaten it away. And by putting the conductive ink on it, or conductive paint, it was actually listed as conductive paint rather than conductive ink. Yeah, the conductive paint actually insulated the magnesium, so it reduced the current flow. So that's my summary. I don't think it helped, but we tried it. On the subject of the electrodes being eaten away, this one's a good example. You see he's hardly moving, and that's been eaten away. I just cut this clip from the build video for that cell. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.